Hello everyone, welcome to Inspire EDUCARE. I am Ruchi and today we will be solving question number 101 of LeetCode, that is symmetric tree. So in this question, we are given the root of a binary tree and we have to check whether it is a mirror of itself, that is whether it's symmetric around its center or not. So let's look at the examples. So we are given two trees like this first tree and second tree. So in the first tree, if I put a mirror through the root of the tree, let's say I put a mirror here. So I have to check whether the left side and right side, whether they are mirror images of each other or not. So we can see in the first example, that is definitely the case. If we go to left and right, 2 is here, it's correctly positioned, and 4 is on the right side of this node, and here it is on the left side, so it is mirroring, right? So for these kind of tree will return true. But if I put a mirror in between the second tree, we can see that till here it's fine, like the second node of both side is cool. But when we go to the root with the node with the value 3, what is happening? Are they mirror of each other? No, they're not, right? Because how it would have been the mirror, if there was a node here instead of here, it could have been the mirror image, right? Or instead of here, the node would have been here, then it would have been the mirror image. But for the given case, it's not. So for these kind of tree, will return false. So I hope you understand the question. So let's talk about the logic behind this question. So what I said is that if we put a mirror between through the root, then the left side and the right side should be the mirror of each other for the tree to be symmetric. So let's say I have a mirror function, right? And what this mirror function does is, it tells I give it two trees. I give it tree 1 and tree 2, and it will return true or false. If these trees are mirror of each other, it will return true, and if these trees are not mirror of each other, it will return false. So can I say, if I give the root of left and root of right to this mirror function, if it returns true, then that means our tree is symmetric, and if it returns false, then that means it is non-symmetric, right? Can I say that? We can say that, right? If the left side and right side are mirror to each other. So this is our first condition, right? Okay, so we have our first condition. So now in this mirror function, we are giving two trees, right? We are giving left tree and right tree. So basically what we are doing is, we are giving this tree, the left tree, which is this part, as you can see, right? And we are giving right tree, that is the right part of our main tree in this mirror function, right? This is, let's say we have, this is tree 1 as represented as n1 and node n2, but wait, let me represent it here, n1 and n2. Now for these two to be mirror of each other, what will be the conditions? Let's think about it. Can I say that the value of n1 should be equal to value of n2, right? If these values are equal, then only they can be mirrored to each other. If these values were different, then why, like, what is the point if these values are different, right? So this will be our first condition. And can I also say, okay, this is 5, not 6. Can I also say that the right side of this n1 should be the mirror of left side of this n2? see, this right side should be the mirror of left side of N2. You can visualize it, right? So can I say that N1 right and left of N2 should be mirror of each other, right? Similarly, can I say the left side of N1 should be mirror of right side of N2, right? N1 of left side should be mirror of N2 of right side, right? So we have these three conditions for these two trees to be the mirror of each other. First, N1 value and N2 value should be same, and the right side of N1 should be the mirror of left side of N2, and the left side of N1 should be the mirror of right side of N2. If these three conditions are true, then I can say that both of these trees are mirror to each other, right? And if both of these trees are mirror to each other, that means our main tree is symmetric, right? So these are like the conditions. As you would have realized that this solution is recursive solutions. So for most of the binary tree problems, those problems can be mostly done using recursion, right? So this solution is also recursive because see, we are calling the mirror function again. We are calling first here for left and right, and then we are again calling the mirror function for checking the right and left and right, right? So because this is a recursive function, there must be some base case, right, for the recursion to stop also. So what can be the base case? Let's see. So we'll check, let's take these two trees, let me zoom. We'll check the right of this and left of this, right? So there will be a point when we reach the leaf nodes, right? Let's say, okay, let me take a smaller example. Let's say I'm given 1 and 2 trees here, and there is 2. So we have these two trees now, and we have to check whether they are mirror of each other or not. So first we'll check, like this is N1 and N2. So our first condition is value. So first condition is right. Second condition is N1 of right and N2 of left. So you can see that when I go to N1 of right, I don't have anything. When I go to N2 of left, I don't have anything. So can I say if N1 is null and N2 is also null and condition, right? Because when we call this second function here, so this will become N1 and this will become N2, right? But now we have null. We don't have any values here. So if I write this case, like if N1 is equals to null and N2 is equals to null, that means these are mirror to each other because there is nothing, right? If there is nothing, that means they cannot be non-mirrored. They are of course mirrored. So if this is the case, it will return true. But let's say if instead of having nothing here, I had 3 here, right? So what would have happened? Our N1 would have become null and our N2 would have become something. So can I say, after checking this condition, if either N1 is null or N2 is null? So we have checked that both of them are not null, right? We know that both of them are not null. But after checking that, if one of them is null, that means it is false, right? For them to be mirrored, both of them should have been null, right? So we can return false here. So this will be the base case of our mirror function. Understood? So like if we see, it would have been null here, right? And then it would have checked here, the left of n1 and right of n2, it would have written, it would have gone on this node, this would have become n1, this would have become n2, then it would have checked. Now because all the nodes are leaf nodes, there is nothing there, so it would have written true, and this would have been become a mirror of each other, right? Then it would have written true. So this will be the base case of our mirror function. So I hope you understand. So let's talk about the code for this question, right? So I'm doing this in C++. So we are given this is symmetric function and we have to complete it, right? We'll be given the is symmetric function. So what I'm doing first is I'm checking whether root is null. Now, if, as I said in my explanation also, that if there is nothing, that means it cannot be not symmetric, right? If there is nothing there, then of course it is symmetric. So this is our first condition. So if we are given that root is null, that means we'll return true. Then what we'll do is we have written this is mirror function that I'll explain in a bit. So if the left side of the root is mirror to the right side of the root, then this function will return true, and this is symmetric function will also return true. And if they are not mirrored, then is mirror will return false, and then is symmetric will also return false, right? So let's talk about the is mirror function. So these are the base cases, right? So what we are doing is we are passing two nodes, node 1 and node 2, representing the root of two trees, right? So in our base case 1, let me write here. This is our base case 1, right? If both of them are null, that means they are mirrored to each other, then it will return true. If there is nothing, then it cannot be not mirrored. And second is, if both of them are not null, but one of them is null, that means it is not mirrored. So like if I put a ball in front of a mirror and but it is showing nothing on the other side, that means it's not a mirror, right? Then what we are doing is we are checking this condition. If the left side of node 1 is mirror of the right side of node 2, and right side of node 1 is mirror to left side of node 2, if both of these conditions are true, then it will be a mirror, right? It is one of the conditions of our that for it to be mirror. And if any of them is not true, then our trees are not mirrored to each other, right? So these two functions are the recursive calls that we are making, and I'm storing the result of both these conditions in a boolean variable called mirror, right? Then what I'm checking, if the right side and left sides are mirrored to the corresponding left side and right side, and the value of node 1 is equal to the value of node 2, this was our first condition, right? If both of them are true, if both of the values are same, let's say in this case that this 2 and this 2 is same, then only it is a mirror, right? If it was 2 and 3, then it would not have been the mirror. So we are checking this in the code as well. If node 1 value and node 2 value is equal and our boolean variable is also true, then will return true, or else will return false, right? If these conditions are not true, then our function will return false. So I hope you understand. I'll run the code and show you. See, it's giving the correct answer, and I'll submit it also. So it's giving the accepted answer. So if you have any doubt, you can put in the comments. Thank you so much for watching the video. Please do subscribe to Inspire EDUCARE if you want more content like this. Thank you so much.